Hello and welcome to the Alpha Software Demo and Q&A webcast. I'm Dave McCormick, VP of Product Management here at Alpha Software. I'm very pleased to be joined today by yet another member of Start Software over in the UK. Today we're going to be seeing something kind of cool. I'm not even going to give away any of it. We're just going to jump right in. But keep in mind, we're also here to take your questions, and type those questions right into the questions box of the GoToWebinar control panel. You can also reach us by email at guides, G-U-I-D-E-S, at alphasoftware.com. So let's get started. Hello, Tom, are you there?
I'm there, yep. Can you hear me?
Excellent, I sure can. I'm going to go ahead and make you the presenter.
Thanks very much.
And you should see a dialog box appear, and there is your screen. Similarity searching.
Cool, that was nice and easy. Right, okay, so yep, today I'll just start off with an introduction. I think Dave's kind of introduced me already, but my name is Tom. I'm a developer at Start Software, and as Dave mentioned, we've done quite a few of these webinars recently. So for my one today, I wanted to do something a little bit different. So what we're going to do today is we're going to show something that I'm going to call similarity searching. So what I mean by this is in a lot of applications, and this should sound really familiar to most alpha developers, you may have something like a grid and you'll have search boxes. That might be a list, by the way, it might not be a grid. And when you do a search, often what you'll do is a sort of contained search that might be, can you find this word within this text, or part of a word in the text, or do we get an exact match? And for a lot of the times, that is a pretty good way of searching data. It's not bad. But today we're going to show something a little bit different, and it might be something that you didn't realize you could do in alpha. So I'm going to move to the next slide, where I'm going to talk about the two different things that I'm going to talk about. So one's quite a basic thing that we're going to do, and then we're going to look at something a little bit more complex. So the first thing that we're going to talk about is something called SoundX. And basically what that is doing a search on a value, but rather than what the value is, we're going to go off how it sounds. So that might sound a little bit strange, but this is actually a feature that's been around for a long time. This isn't actually anything that's particularly new. So maybe a few people have actually used this before, and some people may not have realized that this is actually built in to alpha. It's actually built into SQL as well. There's no sort of extra tools we're downloading here to do this. This is all built-in stuff. So first of all, I'm going to show a demo just to show you how this actually works. And this is what I got on screen. So here we have a list of 4 people on here, and you'll notice these are members of Start Software. If people watch the webinars, these names should all be familiar to you. And basically what a SoundX is, and I'll type in something here, is, like I said, the ability to search a word or get a code for a word based on how it sounds rather than what the word actually is. So the use case for this in this particular example is this is actually going to search on surname, is that somebody like Jack, and poor Jack throughout his life has had plenty of people misspell his surname, because it's an Irish name, and unless it's not maybe so bad if you're here in the UK and certain parts of the US we have a large amount of Irish people, but for some places in the world this is a very unobvious way of spelling burn. So if I just type in the word burn right here, and you can see that's populated the SoundX value. And before I even click search, you'll straight away see that this B60 650, that's a weird one to say, matches this perfectly on here. So if we click search, you can see that it's found Jack, even though I've spelt the word wrong. So before I even go much further on this, you can straight away see how this is useful. Another example would be Robin's name. He has 2 N's and 2 T's in his name, but I imagine that throughout his life he's had plenty of people asking, oh, is it 2 N's or 1 N?
I've been one of those people. In fact, I've spelled it wrong on official things, and I felt very bad. If I had SoundX, I could have just looked it up.
Well, exactly. Yeah, this is solving an age-old problem. I feel it's probably a very underrated feature, actually. So the fact that people don't know it exists, it's
my last name is McCormick, which has 4 different spellings. So I could see that being useful too. Yeah.
Yeah, I should have added you to the demo, Dave. Actually, that would have been real nice.
It's a weird one.
I'll remember that if I ever need to do this again. So So yep, so Robin has two N's, but of course,
Mhm.
oh, so actually I'll just yep wait for that to correct itself. But you can see I've
Yeah.
spelt it wrong. But of course, the spelling of it hasn't affected how the word's actually sounding. So Bennett with one N sounds exactly the same as it does with two N's, and straight away you can see that's allowed us to find Robin's name in this list. So, and this isn't just off names. Names is a really good use case for this. But of course, you could have like a list of customers. You could have something like the caveats to this is it only really works off a single word. So if you have a big long description, you will struggle to use this effectively against a description. We will show a technique later in this webinar where we show how to work with descriptions, but this is really effective for doing this type of similarity searching on words based off how they sound, not how they're spelled. So I will show you very quickly how this is actually done, and this will illustrate the fact that you can do this in a lot of ways. So straight away, the grid itself is based on a SQL view, and you can see all I'm doing on the surname field here is I'm creating a new calculated field, and I'm using the soundx function. So this is actually built into SQL Server. This isn't any sort of extension I've put in. This is actually baked into the database itself. So it's just a function. It's the soundx, and you can see we've got it in the database just here. We're not running any code or anything. There it is. Doing it in, oh, I'm skipping ahead to the later demo. How exciting. Um, in the soundx code here, you'll see on the onChange event for this, let me just bring this up. You'll see we're actually using an XBasic version of this, which is called soundx. So it's actually baked into the XBasic language as well. So I hope that illustrates the fact that soundx is sort of, it's been around for a while. It's baked into lots of different programming languages. It's a very standard thing. And soundx in XBasic will work exactly the same as soundx will work in SQL Server. So in this
Thanks so
case,
much for reminding us of that. That's an incredibly useful thing especially for last names as your use case there. I can imagine many times where someone wants to look up someone and say, I don't know the spelling, just get close. The way you might do with Google, where Google kind of figures out what you mean.
yeah,
That's
exactly. I
yeah,
mean, especially people who like you say, got sort of slightly odd last names. It's a
yeah.
really good tool for like, where you've heard something and you just want to just try your best. And you could even put ridiculous spellings in this. So like, I'll show you for an example of with my name. So my name's not very hard to spell, but of course, I'll say that a lot of people still get it wrong actually, which is surprising. I can spell it completely stupidly here, and we should still find it. Yeah, there we go. So you see, I've just spelt this in a totally nonsensical way, and you can see that
uh,
it's exactly the same because Watkins is pronounced both ways the same,
yeah.
even though, this is just not how you'd ever spell it at all. So yeah, definitely illustrates the point that it's good for last names for sure. So that is soundx.
Mm,
So we can obviously we can go back to soundx, I guess, at the end if anyone's got any sort of specific questions about that. We can talk
sure.
about that a little bit more. But now for the next part of the demo, we're going to talk about something that's a little bit more advanced, and it's still using our database, but we are using OpenAI. So this isn't an AI feature per se, and I want to really stress that. Um, but we are using OpenAI for an element of it. So it'll all make sense when I actually get to it. But this one here, I'm saying if the first one is sounds like, this one is like. And if I show
Mm,
you the demo, I think you'll be able to see what I mean by that. So this is just a list control right here, and this is a list of movies that I downloaded on the internet, and that is the reason why this data is so weird.
mhm.
I was looking for some sample data to do this demo, and I downloaded this off the internet, and I don't really know what I expected, but the really strange descriptions of all these films are actually really good for demonstrating what I'm about to show. So
Yeah.
yeah, none of these sound particularly good films, to be honest with you, but but what I mean by is like is, for example, if we look at this description here, there's lots of ways that I could rewrite this sentence with different words and essentially say the same thing. So, a fanciful documentary of a frisbee and a lumberjack who must chase a monkey in a shark tank. We could describe lots of these words in different ways. So, documentary, we could just say a TV show,
Mhm.
or lumberjack, we could say a woodcutter. A monkey could be an ape. A shark tank, we could just say a fish. So let's try that out and see what we get. So if we type in woodcutter, then we click search, and this has been working all day and it's still working great. So
There's lumberjack.
yeah,
Yep,
so what you can see is woodcutter has found lumberjack. So if we look at all of these results, we're getting lumberjack, lumberjack, lumberjack in every single one. So
that's
how does
great.
this work? And this
Mhm.
and this is why I said right at the start, this is going to look like some, AI trickery right now, and this is actually all being done in the database. So this isn't going to any chat GPT or anything like that. This actual search is being done purely in the database. So first of all, I'll show you what this distance here means, because a few of you may have looked at this and gone, well, what's that crazy number on here? And essentially, this is what we call a nearest neighbor search. So what we're doing here is we're not saying, filter this list by what's similar, because of course it's quite hard to judge what's similar. Um, so what we're doing here actually is we're getting a value for how close we think that the two things are, and we're ordering it by what we consider to be the closest first. So as we scroll down this, you'll see these are getting less and less relevant, and this distance number thereby increases. So, by here, we're not really getting anything useful. And the more we can refine this, in fact, we could say woodcutter, and let's find in Africa. Let's just try this. I've been trying all sorts of combinations to test this, and it's really quite like surprising that it gives you these. Yeah, there we go. So you see now we've got lumberjack in
And now it said
Nigeria.
Nigeria's in Africa, so I'm going to count that. Nice.
Yeah, exactly. Yeah. And this one here is, and what's nice about it as well is that Australia, it's considered that to be a fairly close thing, because of course Australia isn't in Africa, but it is still a country. So that's
Okay.
the sort of way you have to look at it. Sometimes you look at it and think, oh, how does it work that out? But then when you really read the description, you realize how it's decided this. And it's quite surprising, like, and I'll do another example now. Just I've had a lot of fun with this, to be fair. So if I say reptile and an ape, just because I know there's a great one that comes up for this. You can see this one here has a crocodile and a monkey in the description. So straight away, you can see how this could be really useful. So, and a lot of us have
I'm
probably
going with the
used this.
crocodile in this movie, by the way. I haven't seen it, but I'm going to go with the crocodile winning
They
against
really
him.
like their crocodiles and lumberjacks in these films. Like, there seems to be a bit of a theme going on, to be honest, with this data.
This is really cool. Okay.
Yeah, and it's one of those things, if you've ever used something like Netflix or something like that, if you've probably experienced something like this, where you type in something and you think, and it gives you a film and you think, well, how's it giving me that film? I've just typed in something that's just, nothing to do with that film necessarily, but it has still found something that's relevant.
Hmm.
This is the type of technique that, I mean, obviously I don't know the internals of how Netflix works, and I imagine they're doing all sorts of things in their
Yeah.
algorithm to give you a result. But this is the type of technique that, people like Netflix, companies
And
like that.
also, I'm going to say things like Amazon. I remember from early on Amazon, you would type in something like rain jacket, and you would find something that was called a slicker, which is a synonym.
Hmm.
And I was like, I didn't type in any of those words, but it knew what I meant. And this would have been as back far as then like the 90s or something. So I could
Yeah,
really, yeah,
absolutely. Yeah.
product searches and things like that would probably be amazing for this.
Yeah, and I think, yeah, the product search is searching for film, stuff like that. Yeah, anything this works much better when it has more text to compare. The
More
more things
text.
it has to compare, the better the
Yeah.
algorithm basically is. Yeah. So the more descriptive you can be, the best, the better the result is basically. So this isn't so great on individual words. If you're comparing one word to another, you might not get the best results, but when it's lots of text, it's really quite good. And I think the thing about this is like you say, when we think about this type of feature, we think about, like Netflix and Amazon. And I think when we
Yeah.
look at it, we think, oh, it's just some wizardry they're doing under the hood and stuff like that. We never consider the fact that actually what they're doing isn't that crazy actually now, this is a very
Well,
simple demo, and
you say that, but all right, how'd you do it? Come on, we all want to know.
okay, you're right. We've left you all in suspense long enough. So let's look at some code, because everybody likes looking at the code, right?
We
So
do.
basically how this works, and I'll just close this SoundX example.
Uh-huh.
So this is actually is this actually loaded the right? Oh, okay, I think it's frozen on the previous UX, but that's cool. Let me just see. Let me just make sure I'm on the right component. Okay, there we go. Cool, great. So basically, the way that this works is it uses something called PG vector, which is basically an extension for Postgres. So you'll notice, well, you might have noticed in my first example, I used SQL Server. In this example, I'm actually using Postgres. So just a quick one for anyone who's not familiar about what Postgres is. It's just another SQL database, a bit like MySQL or SQL Server. Postgres is just another SQL database. And the reason why I'm using Postgres in this example is because, like I say, they have an extension called PG vector. And this isn't something that's natively built into the database, but it's just an extension that you can add, and it basically gives you all of these features, then built into your database, which is really nice.
Ah,
So yeah, it's just really cool. It's quite extensible. Postgres actually, it gives you a lot of extensions you can just add, and it just adds features to your database basically. So that's really cool. And there's a lot of rumors that PG vector is actually going to be baked into the database for too long because of how popular it is. It's Yeah, I wouldn't be surprised to see it become something that's just part of Postgres sooner rather than later, to be honest. And basically what that does is it gives you a field type called vector, and it gives you the ability to do vector comparisons. So what do I mean by a vector? I'll just uncomment this field here, and then I'll show it to you. And it's going to look a bit crazy, but just sort of hear me out on that. Oh, I haven't run this query for a while, so it's timed out. Cool. It does actually have to load quite a lot of data. So here we see. So this is actually the comparison that it does. So what it doesn't do is it doesn't compare text to text. It compares a big vector like this to another vector. And this is going to look completely crazy, but this is essentially a vectorized version of this. So this is the thing that we use OpenAI for. We send the text here, and I've done all of this ahead of time for these records because there's 1,000 in here just for the purposes of the demo. But we have the text here, we send it off to OpenAI, they send us this back, and that is what we can then use for our searching going forward. So that is the AI element of it that I mentioned.
so there is in
Yeah,
fact an AI. So to vectorize it, you use the AI,
that's
but to
right. Yeah,
compare it, you just use the vector comparison, which is a feature or extension of Postgres. Did I get that right?
yeah,
Cool.
pretty much, yeah. So in and just to show that there's no, just to show that here you can see what I'm actually doing is I'm comparing one record to another. So you can see this is the record I'm comparing, and you can
Uh-huh.
see this is here you can see that this is actually given us, this is the most similar record
Mhm.
to this record. So you can see a fanciful documentary of a frisbee and a lumberjack who must chase a monkey in a shark tank. You can see this one, a beautiful documentary of an astronaut and a moose who must pursue a monkey in a shark tank. So you can see lots of words that are similar: chase, pursue, fanciful, beautiful. The
Uh-huh.
fact it's actually matched words. So what this doesn't do is only look for words that are, you know, you know, opposite, like similar words. If it finds the exact word, it will just go, they are the same. So it's not
Okay.
just a
Yep.
similarity searching. It will find, if you do an exact match, that will be obviously what it considers to be the closest. But I hope this just demonstrates that this is entirely Postgres doing this at this point. So we're not going to ChatGPT and doing any of this. Incidentally, this is the sort of thing that ChatGPT does under the hood. So a lot of people will look at AI and think it's kind of like, some magic thing that's happening. A lot of it is this vector stuff. This is a core feature, and that's why OpenAI have models to do this. It's
Yeah.
because using these vectors is just a big part of how AI actually works. There's a lot more to it than that, but it is a core component of it. So I'll show you how we're actually doing that, because one thing we do have to do is obviously when we type in a search term, we have to then convert that to the
The
vector in order
vector.
to
Yeah.
compare the two vectors. So I'll show you how that actually works in here. So this is just a really basic UX. You can see right here, I've just got this film list. So if I bring up the list properties here of this list, you'll notice that this is based off an XBasic function. And a few of you might look at this demo and think that once you've seen how I've done it, you might think of a better way of doing it. This was a little bit of a rough and ready demo just to show that it works. So I'd love to, if anyone thinks of a really nice way to actually incorporate it into Alpha, would love to hear from you. So just drop us an email on email I had on the first slide. At the moment, this goes to an XBasic function.
Mhm.
So I'll show you the XBasic function, and it's pretty simple. So the first thing we do, obviously, is we connect to our database. So this is straight away. This will look familiar to most alpha developers, I would have thought, who write XBasic. We're connecting to our SQL database using a named connection string. So that's obviously just set up in here, and you can see we've got this um, connection string here connected to Postgres. The Postgres connector is just built into Alpha. You don't need to worry about that at all. It's just, you just connect to it using the dialog on there, and it just connects fine. There's nothing else you need to install. And in fact, if you haven't got the required things installed to connect Postgres to Alpha, it'll just install those for you at that moment in time as well. So that's quite convenient. You'll see what I'm doing here is I'm getting the search value here, and I'm just getting that with just this e.data submitted value here. And then what I'm actually saying is if there isn't a search value, we don't want to do any comparison because there's just nothing to compare. So
Mhm.
we're just gonna get the list of films.
Error trapping there. Yep.
Yeah, so we want to just get the list of films, and we're just going to hard code 0 as the distance in this particular example. So the interesting part now, though, is when we do have a search value, you can see I'm getting this object here. And the reason for this is we're actually using Node.js to do the actual embedding. So there's lots of the nice thing I think about this talk, and is one of the reasons why I thought, despite the fact it's an interesting topic, is it actually uses a lot of sort of basic alpha features
Yeah,
together.
this
It's
is
not
really
like,
great. Postgres connection, Node.js, all that stuff. Sound
yeah,
excellent.
exactly.
Yeah.
So
Yeah.
we've used lists, grids, UXs, XBasic, Node.js, SQL stuff. Yeah, we're using kind of all the bread and butter, like I would call it, the bread and butter stuff that you probably have in every project. And we're doing something a bit different, I think. So that's why I thought it'd be a fun demo. So,
Great.
yep. So here what we're doing is we're getting our API key. If
Mhm.
some of you are looking at this app var syntax here, this is actually something you can do in your project properties. And there's a section in here just called application global variables. And quite often what you might want to do is get this from like a SQL table, something like that. But if you've got some hard coded things that you want to be available throughout your entire application, put them in here, and then you can reference them using the app var dot and then the name of your property syntax. So it's really good for some like hard coded globals. I probably wouldn't recommend putting your API keys in this because they'll end up in your source control. But just to demonstrate this is just the easiest way to put it in for our demo. But I've never actually seen anybody else who's ever like been aware of being able to use this syntax. So that's a sort of
That's
free
very
piece of
cool.
information
Thank
there
you.
for anyone who didn't know that. So
Very handy.
so yeah. Yep, but then getting the text, and then we're using, this is how to interact with Node.js via XBasic. So this is using node request result. There's a few different ways you can interface with Node.js via XBasic, and if that's something that you've not used before and you're interested in looking up, we use it pretty extensively for various things. Just because XBasic is a fine language, but obviously if you're using Node.js, you have the ecosystem of all the libraries that people have written and put on npm
Mhm.
to do all sorts of things, and that is actually essentially the reason we're using it in this case. But what we've actually got in here is we're just using this no request result, which I will show you in a second, but I'll run through the rest of this code first. We're then getting a result here, which is basically our vector, and then we're putting it in an argument, and then you can see we're using this order by embedding, and then this is the actual operator that PG vector gives you. So this is actually an L2 distance. So if anyone who went to university or even did maths to a reasonably high level, I guess it would be high school in the States. I forget the direct translation to, but 16 to 18, I think, is that we learned this at school, and then built on it a bit at university. But this is it's an actual algorithm for comparing one set of vectors to another. I won't go into the algorithm because it's pretty complicated, to be honest, and I'm not sure I'm actually smart enough to explain it in a in a way that would make sense to anybody. So yeah, and then we just run in the SQL. And one thing it does expect is that it's returned in JSON format. So you do have
Uh-huh.
to just do this rs.to JSON. and then
Mhm.
set that to be the return value of the function. It's really as simple as that in terms of how to
Right.
base a list off an XBasic function. And just refreshing the list, which is actually all our search button does. Our search button doesn't run any list actions. All it does is actually run a refresh, because
Mhm.
what that will actually do is cause the XBasic code to rerun, and obviously that will then
To
update
rerun
the
the
list.
function that populates the list. That's so cool.
Yeah, that's it. Yeah. So I'll just show you this.
Oh, we get to see the node too. Fantastic.
Yeah, we'll get to show a little bit of Node.js. So this is the reason why we're using Node.js in this example, because we're using a language called, not a language, sorry, a package called LangChain.
Mhm.
And this is really useful for doing all sorts of AI things. And it works with, it's not like just OpenAI, it works with all sorts of, AI providers. So, if you're using something like Google's Gemini, or, you're using Llama 3 from Meta, or I feels like there's a new one coming out every day, to be honest. Um, this works with lots of different ones. And you can see in here, we're using text embedding free small, which is one of the more recent embedding models from OpenAI. They do also have a larger model, just creatively called text embedding free large. Um, and what that will do is it'll just give you a larger set of vectors. Um, the trade-off for this is why would you use the small when you could just use the large, and that will give you a better result, is price and performance basically. So obviously the large model will cost you very slightly more. There is a cost obviously to this, because obviously OpenAI is doing something, but it's a crazy small cost. I think we
I was
worked out.
about to say my experience, and you probably have a lot more than I do, but my experience playing around with OpenAI and the interfaces that it costs next to nothing. Like I'll put maybe $10 into an account, and I'm not even close to using up one.
Yeah, it's pretty cheap
It's-
actually. Yeah, it's
so yeah,
definitely cheap.
it's very cost effective. Yeah.
Yeah, I think it's something like in my demos I've used maybe a few thousand tokens, and it costs like $1 for like 10 million or something to do these embeds. Or
Right.
don't
Yeah.
quote me on that, but the embedding is just ridiculously cheap, because
Yep.
it's, yeah.
Yeah.
So, and then yeah, we're just using it in this case LangChain, which is also a Python library. So when you type in LangChain, you may see this come up with a Python library. They're built by the same people. They've got a JavaScript version and a Python version. So,
Oh,
and of course, I've not used it too much myself, but
Alpha
obviously
supports
Alpha,
Python as well if you chose to go that
exactly.
direction. Yeah.
Yeah.
Yep.
So if you're, quite, used to using Python, you'd rather use that, you can use LangChain exactly the same, but just use obviously the Python
That's
documentation
great to
version of
know.
it.
Yeah.
Yeah, that works exactly the same. Yeah. And then it's just very simple, just getting that embed, and then I'm just passing it back in this response dot result. And all you got to do is use the send response. That's just a function that gets passed in here.
Mhm.
A lot of this function will get templated for you when you create the node surface through Alpha. So you don't need to, you don't have to write all of this. You just got to write the body of the function basically, and just make sure that you pass the result to the right thing basically.
Yep.
So that's how that works. Just a cheeky plug here as well, actually. You might notice I've opened this in VS Code rather than the JavaScript editor with an alpha. That's
Sure.
purely for that the syntax highlighting is a little bit better. So if I could ask for
We
anything cheekily,
absolutely love that, and we've looked into possibly someday embedding that into Alpha. It's absolutely a great thing.
yeah, I know you've done it with the HTML editors.
Yeah,
They've improved a lot in the last
yeah,
like year or so. Yeah, it'd
yeah.
be amazing if the JavaScript editors could be on that path to improve, and that'd be really nice. Yeah,
I will let the development team know. That's a great idea. Yeah,
thanks very much.
yeah,
Got to get a cheeky request in if you're in the webinar.
absolutely.
Why not? Why not? So, yeah, so that's how that all works. So you can see that's actually pretty simple for something that feels kind of complex, and you think it would be complex. We've managed to do that all in, let's say, 70 lines of code here
Yeah.
and a little bit of Postgres. So I think it's a classic example of how, you see some of these like things online, they look quite advanced when you use them, but they're actually really, really simple if you just, use things that are available to you, and as simple as, your database, and sprawling through the XBasic documentation. So
Excellent. Well, thanks again for reminding us about SoundX, which I know has been in there since I'm going to say the 1990s would be my guess.
yeah,
Probably came over from the DOS version of Alpha 4, if I would be
yeah,
surprised.
Soundex is really old, yeah,
It's
and
an
it's
old one, but it's great. And I had forgotten that last names are such a perfect thing to do. If you're talking to someone on the phone and they say their name, you don't have to ask them to spell it. You could just type it in the way you think it is and then repeat it.
yeah, It does
Oh,
feel kind of like lost knowledge, doesn't it? Yeah.
yeah, that's pretty cool, actually. Yeah.
Yeah, I do have
And
to give Robin a bit of credit on the Soundex one as well. It was I was putting together all the the vector searching and doing all that, and it was he sort of suggested, well, this would be a nice way to sort of build up to that with something that's really simple.
yeah,
So I do have to give Robin a bit of credit for that particular idea. So can't
well
claim
done,
credit for
Robin.
everything.
Yeah. And the PG vector stuff and the OpenAI stuff, and that was very cool. Just one, oh, sorry, one last question. What again was the name of that library that you used in Node to make the encryption to begin with?
Yeah, so that was a
Was it
library called LangChain.
LangChain? Okay.
LangChain, yeah. So yeah, has a Python version, has a Node.js version.
Wow.
Yeah, they're really, really widely used at the moment, so you should have no issue. And the
Great.
documentation's really, really good.
Yeah.
Really, really good.
Excellent. So I don't see any questions here, which I think means you explained it pretty well.
Hopefully.
That's some cool stuff, man. Yeah. If we do have future questions, of course, send your questions into guides@alphasoftware.com.
Yeah, and
I want to thank you
I'll just
very much for presenting today. Uh, Very much look at. Oh, and we've got Tom's contact information there on the last page if you would like to email him.
yep. And
Cool.
it's just if anyone wants to just take a quick screenshot of pretty much everything that I've just said, just to um,
Now's your
just a
chance.
couple of bullet points just to summarize what I've said.
Excellent. Tom, thank you very much. I really appreciate it. Thank you,
No,
everyone
you're
else, for
welcome.
showing up. We look forward to seeing you at our next Alpha Software demo and Q&A webcast. Until then, take care and stay well. Bye-bye.